Welcome to the channel. So the today's video will be on regression analysis. So regression is a task in machine learning where we establish a relationship between one or more than one independent variables which are treated as features and a dependable variable which is often considered as outcome. And it can be done using traditional machine learning as well, but today I want to use an artificial neural network which I will build using PyTorch, and then I want to perform this regression analysis task. So let's get started. So as usual, we need some libraries. So import NumPy, SNP, then import pyplot as PLT, import random, then import torch, from torch import nn and optim, from torch.utils.data, import dataloader and dataset, then from torch import summary. After that, from sklearn import datasets, from sklearn dot preprocessing import standard sklearn, and finally from sklearn dot model selection import train test set. Okay, so these are the libraries that I need for this task. Then I need to load California housing dataset. California housing dataset. Okay, so I will first create a dataset class. So let's call it California housing dataset. Self xy scale data by default it is true. Then condition, so if not torch so if x is not torch tensor and not and if y is also not torch tensor and if this condition is true, which it is by default, then we want to scale our features, which is x. Standard scalar dot fit transform x, then After scaling, we want to convert it into torch tensors from NumPy arrays. Same for y as well. So torch from NumPy y. Then we need to use this built-in method, which is underscore underscore len underscore underscore. So this will return all the samples in the California housing dataset. So return .x. Then finally need to use another method, which is underscore underscore get item underscore underscore. So it will provide us with a particular symbol at a particular index. Index is I. So return self.x I and self.y I. Okay, so that looks okay. So now we can just call this function. So not now. First we need to fetch the dataset from sklearn. Then we can call our function where we can pass x and y, which are arrays, not torch tensors, but they'll be converted into torch tensors here. Let's check the shape. Okay, so we have 20,640 samples in total in our dataset, and 8 is the number of features. So now let's define data loader. Okay, so dataset batch size, it's a 12, and shuffle true. Check the length. Okay, so 1720 is the number of batches we have, and each batch has 12 images. I think this number is divisible by 12. Yes, so it is divisible by 12, so we do not need to drop the last batch. Then we can create a neural network for the regression task. Find the neural network. So let's just call it ANN regression. Self.model will use NN.sequential. Then we will sequentially add a few layers. So in artificial neural network we use linear layers that NN.module offers us. So in features will be 8. Out features, let's say 64. Then we add a ReLU layer. paste. Okay, finally it will be 1. Okay. Because we just predict the outcome, which is the single outcome, and usually it is continuous. So this will be 64 because previous output is 64. Then let's reduce it to 32. This will be 32. This and this will be same, and finally we get 1 outcome. So now we have to just use the forward method to sequentially pass our data through these layers. So just return self.model. This will be our input X. Okay, so let's visualize the network architecture. Summary. Sorry, input size be 12, 8. 12 is our batch size and 8 is our input features. Okay, so this is how our model looks like after visualization. We can see the final output is 12.1 because we want to predict 1 outcome. Then we can define the training batch. So training batch, it will take data, targets, model, criterion and optimizer. Okay, then we put the model into train mode. Output will be model, data, calculate the loss, criterion output and targets. Then the 3 common step: optimizer 0 rate, loss backward, and optimizer step. Then we finally return the loss. After that, set up model, criterion and optimizer. So model is gain and regression, criterion is this is the mean absolute error, and optimizer will use the add-on optimizer. So model dot parameters, learning rate is 0.01. Okay, then we need to write the code for training the model. So let's say that we set Okay, so I will train the model for 100 epochs. Let's create an empty list for epoch. For data targets in data loader, data.float targets.float. So we are just changing the data type from torch float 64 to torch float 32 using this line. Same for this one as well. Then we need to reshape the targets. So targets.reshape shape 0, and then one extra dimension. Sorry, there will be additional brackets here. Then training batch logs, training batch, data targets, model, criterion, optimizer, losses.append, training per epoch loss np.array, losses.mean. Then if epoch plus 1 reminder 10 equals 0, we'll print the results. So training loss. Okay, let's train our model. I'm not using GPU because this is not image dataset. I don't think it will take a lot of time. Okay, first 50 epochs have been completed, another 50 to go. Okay, the training is finished, so now we can plot some losses, I guess. Plot training loss, plt.figure, peak size, plt.plot loss, line width, training loss, plt.xlabel, so this will be y label, matrix, this will be x peaks, y ticks, and finally PLD.legend. Okay, so this is how our loss curve looks like. So it started from above 0.46 something, then gradually decreased, and after 100 epochs it is 0.34 something. Okay, so now what we can do, we can see some model prediction. Features, let's just call it actual targets. So next, iter data loader. So this will give us 12 features and their actual targets, because our batch size is 12. Model.eval will provide these features to our trained model, and it will give us predicted targets. Again, features.float, otherwise error will be getting errors, because if we use float, then it becomes torch float 32 type data, otherwise it is float 64 type, which will not be processed by the model. So let's check our predicted targets. Okay, so how many are here? 1, 2, 3, 4, 5, 6, 7, 8, 12. So as I said, we'll get 12 features and 12 actual targets. So now let's also see the actual targets and see how our model is predicting. So in the first case, actual target is 1.99 something, our model is 1.27. So this is there is quite a difference. Second on 1.25, 1.32, not so much difference. 2.44, 2.69, close. 0.75, 1.04, this is also quite off. 3.08, 3.81, there is some difference here as well. 1.76, 1.64, close. 1.25, 1.19, 0.75, 0.84, so these are close. 0.84, 0.88, close. 3.98, 3.90, very close. 1.36, 1.37, 2.38, 2.8. So last one is also there is some difference, but overall predictions are not bad. If we just plot these two in a graph, then it will be easier for us to judge. So here, instead of this, now it will be actual targets. Let's call it green actual targets. This will predict the targets. Color will be red. Predicted targets. Other things are okay. So let me change this. This is just instances. Everything else looks okay, I guess. Okay, so the green line is our actual target line. So in the first case we see there is quite some difference, but second one, third one looks close. This one also looks close, but there is some difference here. This one looks okay. This one looks okay, but this one, there is some difference here. But overall prediction is okay, I guess. So this is how we can use artificial neural network with the help of PyTorch for a regression task. And here I used California housing dataset, which has 8 features. Please check scikit-learn's documentation if you want to know more details about this dataset. I think that's the end of this video. Thanks for watching.